planet Earth. 4.5 billion years of evolution. It's all going to end. Titanic forces are already at work that will destroy the world as we know it. Scientific investigators take us on an epic journey into the future of the Earth, where apocalypses will wipe out all life and destroy our planet. This is the countdown to the end of the world. Seven and a half billion years from now, Earth will be consumed by fire and vaporized. But by then, it will be unrecognizable, a lifeless alien world. Long before its final moment, our planet could be struck by no less than 7 great catastrophes. One by one, they will turn the jungles into deserts, reshape the continents, and boil away the oceans. Other disasters will destroy the atmosphere, annihilate the animals, and destroy every plant. These are just the catastrophes we can predict. And what of mankind? We could be the first to go. This is the story of the death of the Earth. The first threat to life on Earth comes from the heavens. Right now, a lump of rock and metal, 6 miles wide, traveling at 17 miles per second, could be headed our way. It could strike next week, next month, or next year. But whenever it does, there will be little we can do. We would have very little warning before that threat turns into an asteroid impact. Earth has always been in the firing line.
It could happen tomorrow. It could be 100 million years from now. But it's not a matter of if, it's when.
300 million miles out from the sun, beyond Mars, is the asteroid belt, the rubble of a planet that never formed. 750,000 massive lumps of rock, more than a half a mile across. It's an inexhaustible source of planetary ammunition that gets knocked out of the belt and sent spinning across space. NASA astronomer Professor Don Brownlee knows a lot about asteroids. The record of the devastation they bring is hard to miss.
Just look at the moon in the night. You see it's covered with craters, huge craters. Impacts that happen to all the planets that have happened for billions of years throughout our history. So this will happen.
It already has. 65 million years ago, an asteroid 6 miles wide slams into the Earth. The impact throws up millions of tons of rock thousands of feet into the air, fusing sand into glass in a split second. This one impact wipes out the dinosaurs, a species that had endured for 160 million years. So what are the odds of this kind of asteroid strike happening today? Using the visible impact record on the Moon and planets like Mars and Mercury, Brownlee has come up with an answer.
The frequency of impact of a 10-kilometer object from space, a comet or an asteroid, of the kind that wiped out the dinosaurs 65 million years ago, is on the average about 1 every 100 million years.
When it strikes, it instantly vaporizes every living thing for miles around. The sheer force of the impact buckles and cracks the Earth's crust, creating powerful earthquakes. The force of the winds whips up waves, pushing powerful tsunamis onto the land. Within a few days, the dust cloud blocks the sun, plunging the planet into freezing darkness. An endless winter that would last for more than a year. Hidden within the dust is something far worse. A sudden overdose of nitric oxide destroys 85% of the ozone layer. As the dust finally settles, the lack of ozone allows damaging ultraviolet rays to reach the surface, harming billions of people and killing plants and animals with lethal doses of radiation. By the end of that first year, at least 70% of all life would have been destroyed. Those that live underground or hibernate stand a better chance. This is what killed the dinosaurs. And one day, the same thing could happen to us. Not knowing when the next asteroid will strike makes planning difficult and worrying pointless. There is worse to come. Even if we could plan for the next catastrophe, it won't make any difference. Ice sheets several miles deep, pushing down from the poles, will be unstoppable. A global ice age is coming. How do we know? It has happened before, and one of the first clues was pulled from the La Brea tar pits. To find an ice-loving woolly mammoth was a big surprise. To find it in the heat of California was a mystery. Could California have once been covered in ice? Could it happen again? To find out, scientists need a record of changes in the climate, stretching back tens of thousands of years. It turns up in the layers of sediment at the bottom of the ocean. Marine geologist Professor Peter Domenical is searching for clues to Earth's frozen past.
Deep-sea sediments are really unique archives of past climate change because the sediments in the ocean accumulate very continuously and very slowly over time. So they present us with this kind of history book of past climate change.
These tiny chunks of rock in the sediment hold the answer to the USA's frozen past and to its future. Deposited 10,000 years ago, how they got here is astonishing.
Icebergs carry all these rocks and they hold them inside the iceberg and then they melt. As the iceberg melts, it drops its load. And that's how we find these big pebbles out in the middle of the ocean.
Icebergs once floated off the coast. As the bergs melted, the rocks they carried from the north sank to the seafloor. 10,000 years ago, much of North America is in the grip of an ice age. But what causes a big freeze? The answer isn't found beneath the geologists' feet, but over their heads, in outer space. The Earth orbits the Sun in an ellipse that gradually changes shape over time. The tilt of the Earth to the Sun also changes. Calculations suggested that the interaction of these changes could flip the climate from warm to cold and back again. It's called the Milankovitch cycle, after the man who discovered it. His orbital calculations showed that the Earth flipped from ice age to warmth 10,000 years ago, the exact age of the sediments Domenical has found.
It was shocking when the evidence came out that there was this very close correspondence between the astronomical calculations and then really the geologic record. People were just blown away.
But what about the future? The orbital effect is called the Milankovitch cycle because it happens over and over again. We're
well on our way, actually, into the next ice age. That's something most people don't really fully appreciate. Climate was significantly warmer 5,000 and 10,000 years ago, and then we've been gradually headed into this much cooler climate.
Domenical believes the Earth will be plunged into another global ice age within 30,000 years. If the last one is anything to go by, the next will be worse. Because in the last ice age, there were just 5 million humans. Now, there are 6 billion. Could we all survive? Ice sheets 2 miles thick could cover the land. Cities like London and New York may be buried beneath thousands of feet of ice. Global sea levels could drop 400 feet as water is locked up in ice. Freezing temperatures might last 100,000 years. The food chain collapses. Plants die as they are smothered by ice. Herbivores can no longer find food and die out. As civilization collapses and food and shelter become scarce, our base survival instincts kick in. Dr. Erwin Redlener at Columbia University is an expert in how humans react to catastrophic events. The bad news is, many won't make it.
The major challenges will be to how to keep ourselves from killing each other because of a natural event like a new ice age. Enormous migrations of people trying to escape from the extreme conditions have the potential of causing a tremendous amount of deadly competition for resources, for food, for water, for power.
Billions of people could perish as vast areas of available land are swallowed by ice. But many humans will survive the big freeze in belts of green, north and south of the equator. Here, agriculture will continue, but not enough to support the billions who will now begin a battle to control it.
I think we are hardwired on a genetic DNA level to seek survival at almost any cost. And I think there's pretty good examples of that. People who were prisoners of war, and people lost in hostile environments.
In a few green areas, humans will survive, but the population will be greatly reduced. Civilization as we know it will change forever. And the next ice age is unlikely to be the last. The great ice sheets will continue to advance and retreat, devastating life and civilizations. 250 million years in the future, it gets worse. Life will face an even greater threat and be pushed to the very brink of extinction. The seas will die and the land will become desert. $250 million years in the future, having survived ice ages and perhaps even asteroid strikes, there now comes an even greater threat. The surface of the planet is completely unrecognizable. Life is being pushed to the brink of extinction. This terrifying vision of the future is caused by the same powerful forces that shape the Earth today.
Plate tectonics was one of the two major scientific advances of the 20th century. It allowed us to get an understanding that the Earth is really much more dynamic than we ever suspected.
It reveals that the Earth's surface is made up of a series of massive continental plates that are in constant motion. Where they collide, huge mountains are driven up and massive volcanoes pour out liquid rock. It shapes the face of our planet. Armed with this new information, the geological record opened up like a book, revealing that 250 million years ago, all the continents were united to form a single supercontinent we call Pangaea. This was a hot, brutal world ruled by dinosaurs. Could future movement of the tectonic plates transform the Earth once again into a single vast landmass?
We now know how the plates are moving far more accurately than ever before, and so it became tempting to look into how this might develop if we projected these motions a few million years into the future.
According to Livermore's model, 250 million years in the future, a new supercontinent will form. Africa plows into the Middle East as Antarctica and Australia fuse together. One vast landmass surrounded by a giant ocean.
We end up with a supercontinent which is primarily in the northern hemisphere and a southern hemisphere which is mainly ocean. This will give us a range of habitats within the supercontinent quite different from anything that we see at the present time.
With much of the land hundreds or thousands of miles from the ocean, rainfall becomes non-existent. No plants grow, and as the land absorbs the heat, temperatures soar. It turns to desert.
If we were looking down on the future supercontinent, what we're likely to see is something really rather like the interior of Australia.
250 million years in the future, this new world will be mostly desert, covering over half of the land. So hot and dry that few plants or animals survive. 80% of the species we see today could be wiped out. Those that do survive will have to adapt to less water, less food, and rising heat. Our distant descendants might try to take refuge in the coastal regions. But even here, there's no escaping the dangers of this new world.
Around the edges here, we're probably going to see continuing volcanism, continuing earthquakes.
The tectonic forces that push the supercontinent together are still at work. Now they begin to buckle and split the land at its weakest points. The result is massive earthquakes. Lava exploits these new cracks and bursts out, forming chains of volcanoes. Molten rock spreads over thousands of miles, incinerating every living thing in its path. Life on the land will be tough beyond our imagination, causing mass extinctions. But this is nothing compared with the devastation facing life in the new superocean. In 250 million years, a single supercontinent will dominate the face of planet Earth. It has happened before. By exploring what happened back then, we now know that this single landmass could have a devastating effect on the oceans in the future. A lethal dose of carbon dioxide may cause a mass extinction, which could wipe out 96% of life in the sea. But where will this killer carbon dioxide come from? The biggest natural CO2 producers on the planet are well known, and the supercontinent of the future will have plenty of them. Volcanoes. To understand how the carbon dioxide from volcanoes leads to mass extinction in the oceans, Dr. James Barry has been studying what happens to one particular creature called a brachiopod during similar events.
Oceans became much more acid due to all the CO2 that was released by volcanic ash in over 100,000 years. And that increased acidity of the ocean has caused not only brachiopods, but many other types of animal life to go extinct.
Dr. Barry is trying to understand exactly what happens when carbon dioxide levels suddenly shoot up. Among the first to feel it are shellfish.
These brachiopods are a curiosity. They're one of the earliest sort of real animal life forms that evolved on this planet. 400 million years ago, they were one of the most dominant forms of life on the planet. But they went from 30,000 species down to about 300. They're the poster child for how to go extinct.
Brachiopods had survived everything the Earth could throw at them for hundreds of millions of years. Yet it was volcanic eruptions on land that wiped out 99% of brachiopod species in the sea. Barry's research reveals how. Brachiopods are highly sensitive to carbon dioxide levels. The excess CO2 from volcanoes dissolves in the water, making it acidic.
Once it enters the ocean, it combines and reacts with seawater to form carbonic acid. And that changes the balance of chemistry in the ocean.
As the sea becomes more acidic, the brachiopods die out. In 250 million years, the hard shells of all marine invertebrates dissolve in the acidic water. As their inhabitants die, a big link in the food chain collapses. Their predators starve, and the lack of food goes right to the top of the chain. At the same time as the food chain is collapsing, another brutal consequence of a single supercontinent will be reaching its endgame. 80% of marine species live close to the coastline. With all the land locked up, there's less coast to go around. Competition for the prime real estate gets fierce. The coastline of the future supercontinent could be 70% less than it is today. So the next supercontinent will be deadly. In 250 million years, an arid desert on land and an acid ocean means a mass extinction that will make the death of the dinosaurs look like a sideshow. But amazingly, some plants, some animals will survive. Those that can adapt. Creatures like snakes and spiders that thrive in the heat. Low hardy bushes and types of cacti may be able to evolve. Life will endure for 1 billion years to come. It's only then that the final extinction of life on our planet begins. The end of all life on land. 1 billion years in the future, the world is going to get hotter. All stars, like our sun, go through a cycle of life and death. Today, the sun is middle-aged, but in 1 billion years, it will be that much closer to death. As it burns through the remainder of its fuel, internal processes will cause it to expand, bringing its surface ever closer to the Earth. The temperature will soar. It is now 86 degrees and climbing. For mankind, another 18 degrees higher, and we will have reached our physical limit. Blood thickens, strokes and organ failure follows. Sometime in the next 1 billion years, humanity will cease to function. At this point, we will have disappeared forever from the face of the Earth. But other kinds of life will be able to survive. Here at the California Academy of Sciences, Professor Lynn Rothschild searches the history of past extinctions for examples of what creatures might be able to survive in a world twice as hot as today.
What I'm holding here is an ammonite, and these were extremely successful group of invertebrates. They were wonderful predators, and they went extinct at the end of the Cretaceous. Not their fault. They were wonderful at the time, but they went.
As the sun expands and the world heats up, it all comes down to luck. If you happen just by chance to be better suited to the new world, you'll make it. If not, it's just bad luck. And in the brutally hot future Earth, we already have a fair idea who's going to be lucky.
We see animals like scorpions, like we have here, spiders, maybe some snakes that come out at night. And these are so well adapted to living in these hot, dry environments because they prevent water loss. They do everything they can to keep water inside their bodies. They stay nocturnal.
Only the most extreme adaptations can survive. But as conditions become worse, life on land heads toward its final moments. It begins with the plants. Atmospheric scientist Professor James Casting is one of only a few people in the world to have figured out what happens to the plants in 1 billion years from now. He's discovered that a drastic fall in CO2 will wipe most of them out.
CO2 will drop by a factor of 1/2. That will wipe out 95% of the plants on Earth.
Geological processes are at work today that absorb carbon dioxide and dump it in deep ocean sediments. But like all chemical processes, the higher the temperature, the faster it works. Supercharged by the hot Earth 1 billion years from now, it wipes carbon dioxide from the atmosphere.
It will drop down below the level required to sustain plant life. And that's the fundamental food source on Earth. I mean, carbon dioxide is the food of life. It's what makes photosynthesis work. And with CO2 gone, it's a very different world.
Deprived of CO2, plant life suffocates and dies. The last remnants of our green Earth turns brown and dead. One vast desert covers the land.
It's really hard to imagine a future without any plants. I guess the best way to imagine it is to go up into the desert. In a way, it's a very beautiful environment, but it is very barren, and it doesn't seem like home.
Without plants, the food chain collapses. The plant eaters starve, and their predators follow. Animals, insects, reptiles, and mammals. For life on land, everyone's luck has finally run out. There is only now one place on the entire planet that does continue to support life: the oceans.
If you think about why life both originated in the ocean and probably will be forced back into the ocean in the future, it's because the ocean is far more stable than land. If you go out into the desert in the middle of any continent here, the summers are sweltering and the winters are frozen. During that same yearly cycle, the temperature right offshore here nearly stays the same year-round.
But 1 billion years in the future, as the dying sun swells and the temperatures rise, the oceans begin to evaporate. As the water level drops, they become more and more salty. To understand what the oceans of the future will be like, Professor Rothschild has come to these salt ponds outside San Francisco, where seawater is evaporated to produce salt.
What happens here, and you'd imagine would happen on the Earth, is that as the concentration of salt goes up, 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 many of the organisms that we're familiar with, fish and kelp and algae and manta rays and so on, drop out.
It is the end for life in the oceans as we know it. Whales, dolphins, jellyfish, coral reefs, pretty much everything. All gone, unable to survive in the increasing saltiness of the water.
And at some point, you're left with brine flies, a few little worms, and some of the microbes that you see here. And at the very highest salt concentrations, about 10 times the salinity of the ocean, you only end up with organisms called halophile.
It is the halophiles, tiny organisms that thrive in high salt environments, that give the water its red color. This color is no accident.
Now, during the summer, we tend to get tanned. I've been in the pool, I look a little tanner than I would in the winter. Well, these organisms also have to protect themselves from a very strong sun, ultraviolet radiation. And so instead of tanning, they tend to produce a lot of red pigments, carotenoids. These are the same kind of compounds that you see in tomatoes and carrots and so on. And this orangey red pigment helps protect these organisms from the very high sunlight.
With a blazing sun filling the sky and temperatures rising, only these incredible survivors called extremophiles can take it. 1.2 billion years from now, all other life is gone.
As the Earth becomes a very hostile place, we're back to having a world that's only populated by microbes, very much the way it was during the early evolution of life on Earth.
Extremophiles clinging on at the ragged edge of survival in the last remnants of the ocean. The final hammer blow that will end all life is now just around the corner. 1.2 billion years from now, plants and animals have been wiped from the surface of the Earth. Only microbial extremophiles survive in a rapidly evaporating, increasingly salty ocean. For the oceans, time has finally run out. The brightness of the expanding sun boosts average global temperatures to a blistering 100 degrees, nearly double than today. Professor James Casting is investigating the devastating effect this has on the oceans of the future.
Well, we think that the Earth will start to lose its oceans when the sun gets about 10% brighter than it is today.
His findings confirm evidence gathered by Apollo astronauts in 1972. Hydrogen is escaping from the Earth. Water is made up of 1 part oxygen and 2 parts hydrogen. So what the astronauts were seeing was the infinitesimal loss of the oceans into space. Today, this amount is nothing serious, but 1.2 billion years in the future, when the temperature is 100 degrees, the process goes into overdrive. Faster evaporation now saturates the air with water. As this water rises to the top of the atmosphere, ultraviolet light from the sun splits it into its 2 component parts, oxygen and hydrogen. The hydrogen is so light, it floats off into space, lost forever. What Casting discovered was that from full to empty, the whole process of losing our oceans could take less than 200 million years. Without water, life cannot exist. So to find out when this will happen, he had to look at a planet not unlike the Earth that lost its oceans in the same way.
Well, I got interested in the future of Earth's oceans by working not on Earth, but on Venus.
Physically, Venus is almost a twin of our planet. And billions of years ago, it might have been even more similar.
May well have had liquid water on its surface at one time, just as the Earth does now. But it was too close to the sun. It lost that water by what we call a runaway greenhouse. It's likely, in my opinion, that Earth will follow the path of Venus at some point in the future.
Studying Venus helped Casting estimate when we will start to lose our oceans. The answer came as a shock.
Well, up until we had worked on this problem, many scientists thought that the Earth would retain its oceans for at least another 3 or 4 billion years. But we were able to show that bad things start to happen much earlier than that. The oceans could be lost in 1.2 billion years.
With the water gone, dry salt crusts like these are all that will remain of the Earth's magnificent oceans. Is this the end for life? Incredibly, a new discovery has shown that even without water, basic life forms can survive. But for how long?
Although we'd known that organisms could live in very high salt, we knew that they could also be trapped in solid salt. But what we didn't know is that while they're in the solid salt, it's more than them being in suspended animation, that they are actually still metabolically active. They're still breathing and eating and excreting and doing all the sorts of things they need to do, but at a very, very, very slow rate. So that was really an astounding discovery for us.
In 1.4 billion years, with the oceans finally gone, extremophiles will survive in the solid salt, but just barely.
These organisms will be able to survive a good deal longer in a salt crust like this, even in the absence of water. They won't be able to survive forever like that, but it'll buy them a little time.
Perhaps another few million years. In that time, their main protection will be the red color that acts as a sunblock. While they live, they will transform the way our planet looks from space.
People always think of the Earth as this beautiful blue planet, you know, the pale blue dot in the sky. But the fact is, for almost half of Earth's future history, it will be a Barbie planet. It will be covered with pink salt.
This is the Earth 1.4 billion years from now. The extremophiles cling on in an increasingly desperate fight, but the rising temperatures as the sun brightens eventually defeat them. By 1.6 billion years into the future, the temperature has climbed to 224 degrees, far above the boiling point of water. Life finally loses the battle. The last remaining extremophile dies.
There are several poignant moments in geologic history. The Earth losing its oceans will be the most poignant of all, because that really will be the end of life as we know it. And unless we've figured out how to colonize other planets, then life will come to an end. It's a pretty sobering thought.
The time of the pink Earth passes. Our planet is reduced to a brown, featureless world. Unless we have found a foothold on another, this is the end of life in our universe. For the next 6 billion years, our dead world orbits the dying sun. Only an astronomer can see this far into the future, to the Earth's final moment of existence. Dr. Robert Smith from the University of Sussex has unraveled the Earth's ultimate fate. But his journey of discovery has taken some unexpected twists and turns. The process begins as the dying sun continues to swell in size.
The sun getting bigger will have severe consequences for the Earth, because we predict that the sun will get at least 200 times its present size.
All stars go through a cycle of life and death. Astronomers know this because they can see stars that represent every stage of life that our sun will go through. In 7 billion years, our sun will be close to death. The sun is now 1,000 times brighter, 200 times its present size, and still growing. The heat literally dissolves the face of the Earth, wiping away the last of its uniqueness.
As the sun gets bigger, the mountains will start to melt, and instead of having high mountains and deep ocean depths, everything will flow into a uniform sphere, be featureless, and very, very hot.
Earth's surface is now melting in 2,500 degree heat. The surface runs with liquid metal. Our planet is utterly unrecognizable, a totally alien world. The end is now close. But Dr. Smith's calculations revealed a last-minute escape might just be possible. $7.5 billion years in the future. The mountains and oceans have been erased from the Earth's surface. The temperature is over 2,500 degrees. It has been lifeless for 6 billion years. Now the Earth itself is about to die. At the heart of the dying sun, helium is reaching a critical stage. It's becoming so dense, its atoms so crowded, that the core is becoming explosively unstable. It now takes on its final form, a red giant, 256 times bigger than it is now. It fills the sky.
First of all, you would see the size of the sun beginning to increase. It would get redder, it would get brighter. At the moment, we're used to seeing it about the size of the full moon. Then it would get bigger and bigger, it would fill more and more of the sky, till eventually when it became a red giant, it would probably fill something like half the sky.
As the sun burns up the last of its fuel, it expands outwards. Now almost 200 million miles in diameter and swallowing everything in its path. Is this the fate of planet Earth? When Dr. Smith first tried to find out, the figures showed that as the sun gets bigger, it loses its gravitational grip on the Earth. The chain is broken, and our planet drifts off into space, potentially escaping a fiery death. It seemed that Smith had saved the planet.
It was a good feeling that we'd saved the Earth, and indeed some of the newspaper headlines said exactly that.
But then one of Smith's colleagues took another look and produced new calculations about the red giant. These seemed to suggest a radically different picture.
When we came to look at the calculations again, we realized that we'd missed something out. We realized that there was a missing effect which we had to take into account, and that's to do with tides.
What they hadn't taken into account are the tidal effects of the Earth on the sun. The Earth's gravity will create a tidal bulge on the surface of the sun, in much the same way as the moon affects the rise of the ocean tides on Earth today. This bulge, in turn, creates a drag on the Earth, pulling it back towards the sun. Smith set to work using the new data to find out just what would happen now.
We didn't know what to expect when we first put in this additional effect. We hoped that even when we put in the tides, the Earth would still escape.
Smith announced a very different set of results. The news was bad. The tidal effect chains the Earth to the sun.
When we came to look at this problem again and put in the extra effects and realized that the Earth would in fact not survive, we decided to call our paper Doomsday.
The surface of the Earth is now nearly 2,500 degrees, hot enough to melt metal. The outer fringes of the sun reach out to engulf the Earth.
If we try to imagine what it would look like to see the Earth disappearing, just be like an asteroid crashing through this Earth's atmosphere. It will burn up completely, it will vaporize, it will disappear, it will become part of the sun, and it will be as if it has never been.
12 billion years of planetary history ends. The death of planet Earth, engulfed in flame, vaporized by the sun, reduced to atoms.
Sort of dust to dust. But it's not such a bad fate, because those atoms, your dog's atoms, your car's atoms, they go out into space, and what do? They end up forming new stars, new planets, and maybe even new people.
It's a cruel act of fate that life-giving stars will one day go bad. Big changes are coming. By understanding how Earth worked in the past, and how it works today, science is beginning to understand what the future may bring. The death of the Earth is already laid out in front of us. It's written into its geological past, and literally into the stars above us.